Hey everyone and welcome back. In the previous video we have learned how to connect to media server as a publisher. So right here inside the stream publisher initialization, we want to send the generated packet to the server. So when it was connecting to the server, it was sending the signal that says that hey, the user is connected. I don't have it inside my log right now, but we have to send it to our signaling server, signaling socket clients, and send message and the generated packet, this one. So you have to make sure you are sending the generated packet from stream publisher to the backend server. So this one is for opening the clients or the socket to the backend. So we want to publish our local stream, and then it's time to handle the incoming message from the servers. For example, the list of current users inside the chat room, and also whenever the new user is being joined to the chat room. So for that, we will write a function that is named handle signaling message and pass the message to it. So let's create this function here, and the message is going to be of type signaling or signal server message model. We use the when statements and check when the message.command is room users, which is the initial signal when the user connects to the chat room. We simply use handle room users function, pass message to it. Same goes for user connected and use handle user connected. Let's create these two functions down here, or maybe here. Private fun handle room users, and same for handle user connected. Okay, so far we know how to publish our stream to media server. But right now imagine 3 people inside the video conference are broadcasting their own local service. Let me show you the diagram. Right here, client 1, client 2, and client 3 are streaming to the SFU server, and the links are available. So it's time to create a consumer or a client to watch the other streams. So to do that, let's go ahead and create another helper class named StreamClient. This is pretty much the same as the stream publisher, but with a difference that will only receive the media stream from the publishers. So let's go ahead and check what's inside it. It will have a simple constructor. It will import the WebRTC factory, JSON, and the callback of type StreamClient callback, which I'll add in a second. Down here inside this class, you can see it has the onMessage generated, onStream ready, and onClient disconnected. So let's go ahead and see what's inside this. We will have 2 main functions. First one is start clients, which will get client user ID type string and client username type string also. And we have the destroy function to stop the client from being observers, to stop the client. So up here we will have the same variables as the stream publisher. The first one is media server socket of type media server socket client. It's going to be null initially. And the next one is RTC client, type RTC client, and it's going to be null initially as well. So let's go inside the start client and set up our media server using new media server socket client and pass JSON to it. We simply want to call init on it and get stream path this time. Client user ID. Let's import this function again. And for the listener, we simply want to use the anonymous of media server socket clients dot media socket callback. Let's implement the members. Now it's pretty much the same as the stream publisher. Whenever the WebSocket is connected, we want to send a signal to our MediaSocket server that says, hey, we are requesting for an offer. So we will create the media server message model, and the command of it is going to be request offer, just like that. And down again inside the onRemote socket client new message, we want to check if the message that's command is equal to offer. Now it's time to init remote RTC client, which is exact same as the stream publisher. Let me create this function inside here. Private fun init remote RTC client, and it will get the client username, type string, and down here we will do the same with the publisher. Use the run catching RTC clients on destroy and make it null, and then again reinstantiate it. WebRTC factory dot create RTC client, and for the observer we simply want to pass something like this, and for the observer I'll use dot object that extends from my pure observer, simply like that. For the listener I'll use the anonymous class again. It will extend from RTC client implementation and use the callback, transfer callback. Let's name them like this. And for is publisher mode, we make it false. Let's implement this one here. We simply want to use media server socket and send data to host and pass data to it. And up here I want to check 3 functions and override 3 function on connection change. I want to check if new state is equal to disconnected. We want to use the callback, and on client disconnected pass the client username to it. The next one is on ICE candidate. Again, we simply want to check if it's not null. Then RTC client on local ICE candidate generated. And the last one is on onAddStream. We simply want to use the callback and onStream ready as P0 and client username to it. So right here, whenever we init the remote RTC client, we wanna use the offer and get and extract the STP and candidate. So use STP and let RTC client to use on remote session received and give it to WebRTC session description. Same goes for the candidates of it, and use a for each, name it ICE. We simply want to use RTC clients and on ICE candidates received and pass ICE to WebRTC candidates. Now after that, it's time to answer to this offer with the message.id. So there are some times that the media server cannot create offer whenever we request offer to it. So we have to try again every 1 second to ask it, hey, please make us the offer. So in such a case, we will see the message dot code is equal to 404. So on these scenarios, it means that server could not create the offer for us. So we use coroutine scope and pass dispatchers.io. We launch a coroutine scope with delay for 1 second, and then we want to send the media server a new data to do the creating offer again. So the command is going to be request offer. It's exact same as this one. So we keep asking till it creates us the offer. That's some unusual bug if it comes up, so we have to handle it properly. Let's set up the destroy function as well. We simply want to get rid of the media server socket and also the RTC clients to make it undestroy. So right now we know how to create an stream client. We have to move forward and use it inside this main view model. But this video is already too long. Let's move to the next video and finish everything we have done so far. So till the next video, see you everyone.